All right, so on the last lecture, we introduced the course, and today the idea is that we should have a short introduction to programming. For today, you should have read the chapter 1 in our course literature, and if you have done that, this will be a little bit of a repetition for you guys. But I know that there is a lot of students who have not got their book yet. Then this will be a little bit of an introduction, and then when you read this chapter in the course literature, that will be so this will be more like an introduction before you read that chapter. Um, and I think it's good to have something that is a little bit easier the first week. There is so much new stuff when you start studying that it might be nice to take it a little bit slower in the courses the first week. But today we will have a short introduction to programming. And why will we do this? Why is this important, what we're talking about today? Well, I think it's important to talk about it, that program is not something that is, how should I say it, that it's not something strange, much like we use Microsoft Word when we want to write a report, or we use a web browser when we want to browse the web. We use a software or a program where we program. So much like we do any other thing on the computer, we will also do programming, and we will be assisted doing so in a program, much like the other ones I mentioned here, Word or a web browser. So hopefully throughout today you will see that that's the case. We will also talk a little bit about the connection between hardware and software, and if this is something that we at this level really have to think a lot about, or is it something that maybe we don't have to think that much about right now? And it's good to know something about that there are different programming languages and they work a little bit differently. We're going to touch on that today too, and hopefully we will be able to have a sneak peek at some Python later today too. All right, so hardware. And before we take a look at what we see on the screen now, I think what we will do is we will switch to my tablet and I will draw a little bit. So let's see if I can manage that. There we go. So if we want to represent a number, we as humans, we want to represent a number, we usually do it this way. Oh, let me just see if I can manage to write something here. Maybe we write it as 42, but that is not how the computer sees it. The computer uses another way of representing numbers and data, and it would look something like this. And it looks very weird if you've never seen it before. You will talk much more about this in another course, how this actually works, but I'm going to try to quickly explain it now because I think it's good to have just a little bit of knowledge as we start talking about the other parts today, when we're talking about the computer and so. So how does this work? Well, if we take a look at what we see as the number 42, that is, let me see here, I'm just getting confused. It's the decimal numbering system. And what the computer works with is the binary number system. And if we look at the binary number system, it consists of only zeros and ones, and we read it from the right. So if we take a look at the numbers, the zeros and the ones, the first one is worth 1. And then each time that we move to the left, we double that number. So the next one is 2, and then we have 4, and we have 8, 16, 32, 64, and 128. And with the binary numbering system, if we want to represent the number 42, we must use ones to activate some of the numbers. We see here we have 3 ones, so we have activated 2, 8, and 32. And if we add those together, we see that we end up with 42. So that is how the computer represents the number 42. And should you have any questions at any time, please just write them in the chat, and then I'll try to answer them as we go along. So that is just quickly how the computer represents numbers. If we have that with us, and then we go back to the slides, let's see if we can do that. And now we can start talking about the hardware. And just a quick check, how many here have built their own computers? Maybe it's for gaming, or maybe it's just for getting it as cheap as possible, or helping someone out, or just for the fun of it, really. Oh, I can see that there is a lot of you guys. Nice. Yes, I should be recording. I will double check. Yes, the recording is on. And the letters, we will get back to the letters in just a second. So we will see how we represent the letters. But as someone mentioned in the chat here, it uses ASCII. All right, so there were a few people who have built their computers on their own, and you will probably recognize the things that is mentioned behind me here. But for those of you who have never built a computer on your own, all these things that we see behind me, those are parts of a computer, and together we usually just call them the computer. But there are many things that you need. So you need a monitor, you need a motherboard, you need a primary and secondary storage, and so on. And usually when we talk about computers, we mean PCs, like gaming PCs or workstations. But there are different kinds of computers. There are servers. Some might have a server at home. If you have a smart home, maybe you have a server controlling your smart home. Or if you have a server where you put your files or backup. You could also have it for other stuff. But what we usually think about as servers is, if we have seen it in a movie, maybe there is a server room where there are these cabins full of servers. They are also computers. And if we go from the big to the small, there's also embedded systems. Usually we don't build them ourselves using components like the ones behind me here. But there are computers in TVs, mobile phones, cars, instruments, today even in light bulbs and security systems. So we have computers everywhere. But when we talk about the computer, about the hardware, as a programmer at this level, what do we really have to worry about? Do we have to know everything there is to know about hardware and the different components? I would say that it's good to have a general knowledge about what different parts there is in a computer and how they work. But um, I would say that it is enough to know about the parts, and the level that they describe it in the book, I think, is good. We don't have to have any deeper knowledge about the different parts at this stage. Um, of course, if you're going to work as an engineer and you're going to work with the hardware, then you have to know about the hardware. But generally speaking, I would say that um, not so much. We don't have to care so much about it. The parts that are important to us is usually, I would say, the primary storage, the RAM memory, and the secondary storage, which is the hard drive. And that's not because we need to know exactly how they work, but the computer is our working tool, and we want it to be as fast as possible so we don't have to sit down and wait while it's doing something. And along the same lines, at this stage, I would say that a good monitor, mouse and keyboard is important too, because that is how we interface with the computer. That is our working environment. But exactly how the individual parts work, we don't need to know about that at the moment. And all right, we talked about how information is stored in the computer, in the memory, in the hard drive. But what if we want to store a letter like A? We saw a question about it here previous in the chat too. Um, what the computer have to do then is that it have to translate it. So it uses something called an ASCII table, for example, and it looks to see that, all right, the user wants to store an A. Let's first transform that into a number. And it uses this table and sees that A happens to correspond to the number 65. Then when it knows the number, it can take the number and translate that into binary. So we see the ones and zeros behind me here for the number 65. So that is how the computer stores other information than ones and zeros. It translates them into ones and zeros. Luckily for us, this is not something that we usually have to think a lot about as programmers. It's done under the hood, so to speak. But it's good to know a little bit about what's going on in the computer. And speaking of translations, there are translations going on everywhere when we're working with computers. Another example would be if we have an embedded system with a very little memory, then maybe we have to come up with a clever way of representing our data that we want to store. Or if we want to send something over the internet, of course we want to send as little information as possible so that it doesn't take so long. So then maybe we do a translation from the information we have to something that we can send. Programming languages. I think this picture gives quite a good overview of how programming languages have evolved over time and how complex they are. The oldest languages are the ones in the bottom here, closest to the computer, and the newer ones are in the top, close to the human here. We could we'll continue and we'll see how it goes. Maybe we'll have to change something around, but we will continue for now. I'll just do like this so you can see me a little bit bigger too. All right, so what I was saying is that the oldest way of having a programming language was in the very bottom here. So those are the oldest languages that work that way. And then as time progressed, we moved upwards. But if we start from the bottom here, the computer only understands machine code, and it was with this machine code that we could make the computer do anything at all to begin with. Using machine code, every instruction is very simple and very close to the hardware. For example, you can fetch some data from the memory, or you can add two numbers together. But it is very time consuming to write code using machine language. And it's really hard to read it too. It's just a long string of ones and zeros. And as it was so tricky to write machine code, the people back then had to come up with something else because it was not sustainable. And during the 1940s, they invented assembly language, where you use mnemonics instead of the very tricky binary instructions. You could also use symbolic names for the memory. And to write your programs, you use this assembly language, but then to run them, you had to translate them to something that the computer understood. And this was done using a small program called an assembler. Today, we rarely use assembly language. It's sometimes used when you have a strict real-time requirement, for example, in medical devices, then sometimes it's used. Today, in the very most cases, we use something called high-level languages. And it's a lot easier to work with, to write it and to read it and to work with it. In many cases, it looks like written English text, so it's much easier to work with. But one of the biggest benefits is that we don't have to keep track of how the computer works. So we don't have to keep track of how the CPU works or how the memory works. That is all taken care of by the computer. Of course, using an abstract method like this doesn't come for free. There is a little bit loss in performance, but as I said, it's much easier to work with, and it wouldn't be feasible to write everything in low-level language today. And if we take a look at what we see here, you can still see it in good quality, can you not? Cool. What we see here is that we have, generally speaking, two different kinds of programming languages. We have interpreted languages and we have compiled languages. And if we start by looking at the compiled ones, what we do here when we program in a language that is compiled, we write our code, then we use a compiler to compile it down to native binary code, to machine language. Then later on, when we want to run our program, we have this already compiled file that we can use. So then we run that file, the runnable file that we get out of compiling our code. On the other hand, if we take a look at interpreted languages, we still have to write our instructions, of course, our code, but it is not compiled. Instead, we have something called an interpreter, and when we want to start or run our script, the interpreter will read each instruction from our script one by one and execute them. So it reads the first instruction, does whatever that one says, then it reads the next one and do that. So it is not prepared beforehand into an executable file. Here is someone asking about JIT, and I will not go into detail about it, but what the meaning of it is, that even if you have an interpreted language, what you can do is that you can try to optimize it beforehand. So when it comes to running it later on, it will have some performance boost. And usually it's done with languages that is compiled into intermediate languages like JavaScript or Java. All right, so but if we look at some pros and cons here, and a pro for the compiled languages is their performance. As it's already translated into something that the computer understands, it is much quicker to run. So the performance is better if we used a compiled language like, for example, C or C++. And if we look at the interpreted languages, for example, Python is an interpreted language. One of the benefits here is that it's cross-platform, it's platform independent. What that means is that if I write a Python script on my computer and then I send it to you guys, you can run that script right away as long as you have the Python interpreter. But on the other hand, if you are using a compiled language on a Windows platform and you compile your code and send it to me, I cannot run that on my Mac. Then what I have to do is that I have to recompile it on my platform. So we have performance on one side and portability on the other side. Yes, all right. I was just checking the chat. And if you know programming since before, it could be good to know that learning a new language is always easier. And if you're just starting to learn programming, this is the first programming language you will learn. It might be comforting to know that now that we learn Python, and you learn how the different building blocks of a programming language work. When you will learn a new programming language later on, it will be easier because you have the basic understanding of how programming works. And let's mention a few words about Python. As we mentioned last time, Python is really popular at the moment, but what a lot of people don't know is how old Python is. The idea of Python, or the idea to creating this language Python, was born in the late 1980s by a guy named Guido van Rossum, who is the inventor of Python. And then a few years later, in 1994, the first version, or version 1 of Python came out. A few years later, in year 2000, version 2 came out, and there were some new things in that version. For example, Unicode and list comprehension, which is still used and very popular today. But the biggest change when we came to version 2 was the process that is used when developing Python, the language Python. It's much more transparent now. And then yet a few years later, we are now at year 2008, version 3 of Python came out. And that is the current version that we are using. It is not backwards compatible. So if you had an old Python program, it cannot automatically run in the new version 3. So if you had developed it in Python 2, it's not 100% sure that you can run it in Python 3. And one of the biggest goals or ambitions with this version 3 when it came out was that there should only be one way of doing something in Python. And where is it used? It's used in a lot of places. So if you are into website development, or if you want to do some automation of tasks on your computer, if you do data science or data analysis, Python is a good choice. Machine learning, there Python is very popular. But you can also use it for regular application development if you want an application on your computer. And for testing, if you want to test something, then Python is also a good choice. And it's some of the benefits, we talked a little bit about that last time too, but it's easy to use and understand, and there is rapid development in Python if you consider from when you start to think about developing an application or a script until it's finished and you have run the script. So from start to finish, then it's fairly quick. And there are a lot of libraries in Python that we can use. So there's a lot of functionality either built in or that we can use as libraries that someone else has provided for us. So those are all pros, but some cons is that it can be slower than other languages. For example, the compiled languages. And as it's so popular today to have apps on our phones, I would say that it's a drawback that you cannot use Python natively on Android or iOS. If you want to use Python to develop for mobile phones or mobile units, there are a few extra steps that you have to take. So I would say that is a drawback. So, but just to clarify, so even if a drawback is that the script might be slower, to develop in Python can sometimes be quicker if you consider the time when you're designing and when you're coming up with a plan for how to solve it and then actually writing the code, even if running the script is a little bit slower. All right, and why did we choose it? We have covered this earlier this week, but to reiterate, it is a popular language today, and it's easy to learn, especially if you haven't been programming since before. And it's used everywhere, so it's a good tool to have in your toolbox. All right, if there is any questions, just write them in the chat, please. And if we start to learn Python, there are something that we will see fairly quickly, and that is interactive mode and script mode. So what are those? What's the difference between them? So you can use Python in two different ways. And if we look at the interactive mode, it could be seen as a way of testing out new things. So you can send your instructions or your commands directly to the Python interpreter. All right, so it's a way of testing things, I would say. And what we are doing in interactive mode is not recorded, or it's not saved. If we want to save what we're doing, we should be using script mode instead. And what we do in script mode is that we write down all our instructions in a file, and then we ask Python to run that file for us. So if we want to save our script, we use script mode. And interactive mode is rarely used. Maybe sometimes if you want to try something quickly, you would use it, but most often not. And in this course, we will use script mode. And I was thinking that we should look at an example of these two. But before we do that, I just want to mention the terminal. Before we had a graphical interface for Windows or for Mac, we used to write out all our commands for what we wanted the computer to do. And today, when we have the graphical interface, we are so used to having a graphical interface on our computer or on our phones. It might seem a little bit old and meaningless to use a terminal where we write our commands to the computer. But in practice, as a programmer, we often use the terminal as it gives greater control of what is happening. And you will have to learn how to use this terminal, or as it's called in Windows, the command prompt. It's not required for this course. I will try to sneak in a few examples here and there maybe, but for future courses you will have to learn how to work with the terminal. And as I said, I will try to sneak in a few examples. So let's see if we can do one. All right, so maybe we can continue with this one and we will see how it goes. Give me a second here and I will just I will just try to get the terminal running and we will switch to my desktop. Here we have it, and what we want to do now is that we want to try to use the interactive mode. So we can do that by, if I can type here, by just writing Python. And now we're in the interactive mode, and if I can do something here, I can, for example, ask Python to calculate 1 + 1 for me, so we can use it as a basic calculator, but we can also give it Python instructions. So for example, I can ask Python to print hello world, and we will see that it responds by printing hello world to the screen. And you could see this as a way of I don't know if you have ever helped someone bake a cake or something, and you are standing there holding the recipe, and you're telling someone else, your friend, who is helping you, one instruction at a time. You tell them to do something, they do that. Then they're just waiting for your next instruction. And that's the same that's going on here. We are telling the Python interpreter to do one thing at a time. On the other hand, if we're going to try to use script mode, we can still do that from the terminal here. So what I'm going to do is that I'm going to navigate my computer not using the graphical interface, but instead I'm going to use the terminal to change to my desktop folder. And we will see that when I create a file here, it will also show up on my desktop here. Or maybe you can't see it right away as I'm just sharing this screen, but I will try to show it to you later. We can maybe try to share my screen instead. Now you should be able to see it as it shows up. All right, so we will use a simple text editor to create a Python script. And Python scripts, they end with .py. And while in here, we will tell it some instructions. Maybe we can tell it to print hello world again. and we'll give it one other instruction. So it will also print, we will learn programming. So we have two instructions in the same script. And now what we can do, we can use Python and hello, which is the file that we created, which we can also see up here. And now we see what it does is that it's running both those instructions. And we talked about the recipe before. So this is kind of like taking the recipe and giving it to our friend. And now our friend can just follow all of the recipe at one go. All right. That was the terminal. Let's see if we can get back to our PowerPoint. See if I can share that one. Give me a second here. There was a question if I can provide some resources. I can see if I can find some, and then I can provide them later on for you guys. All right. And now you do see the PowerPoint, right? In good quality too. Yes, cool. Thank you for helping me out here today. All right, so problem solving. You will do yourself a big favor if you start to solving problems in a structured way. Otherwise, you risk just sitting staring at the problem description, not knowing where to start. Or maybe if you're trying to fix a bug, you're just staring at the code without a plan for how to actually find the bug that you're looking for. Sometimes I saw this when I worked in the industry as a consultant, where colleagues sat and just scrolled around the code trying to find a bug for days, in the end maybe gave up because they couldn't find it. They weren't structured in what they were trying to do. And I think this will be more and more important for us as programmers to be able to solve problems. We talked about it earlier this week, that maybe in the future an AI can help us generate code, and then it will be much more important for us to be able to solve problems and tell the computer what to do. So it's something that is important to learn. And we're going to use Polya's problem solving technique, which has these 4 steps that we can see here. And we will take a look at them. If I can manage to change it so that we can see it. And if we take a look at my web browser, which you should see now, what we can do is if we go to our course and then we go to any of our exercises, the first one, for example, there will be a link to a document about the Polya's problem-solving technique. And in here, it describes the 4 steps. And the first step, it's really about understanding what we're supposed to do. What is asked of us? What is it that we should try to solve? And here we can ask ourselves questions like, do I understand all the words? Or is it something that I have to look into? So just understanding what the problem is. The second thing, the second step is to devise a plan. And this method was originally for solving mathematical tasks, but it works equally well for other problems, like for example in programming, if we adapt it a little bit. So here we see some examples of how you can devise a plan, but you can also use, for example, a flow chart, or you can use a pseudo code, just some way of thinking about the problem and coming up with a solution. Just checking in on the chat here. All right, and the third step is to carry out the plan. So now we have understood the problem, we have come up with a way to solve it, and now that we have a plan for how to solve it, in the third step, we should carry out that plan. So looking at the plan, we should solve the problem, or in our case, write the code. And when we have done that, the fourth and final step is to look back, to reflect. All right, what did I learn from this? What can I use in the future from what I've learned now? Did I actually solve the problem or not? So it's good to take a step back and think about these things when we normally think that we are done with the task, but then we have the fourth step, which is look back. And if you take a look at this document, there is more to read here, where you get some hints of how you can do the different steps, but I'll leave that for you for later to read if you haven't already. Maybe what we should do is that we should actually look at an example. So let's see if we remember these 4 steps that we have here: understand the problem, devise a plan, carry out the plan, and look back. Let's do an example together. I'll just prepare it here and then I'll share it with you. Let's see if we can find it, because you cannot, the quality is good enough to read it. You think, oh great, then we will go with that. Good. So I'll try to write a little bit bigger. So here is the problem that we are going to work with. Your friend have called you and asked for your assistance. Your friend does not know how to make coffee. Can you give your friend some instructions? All right, so if you think about the first step, understanding the problem, what we need to do, when I read this, I interpret it as what we need to do is to, a little bit big maybe. Let's see if we can make this a little bit smaller. We need to make coffee. That is what we need to do. And then we also need to give your friend some instructions. So that is what we need to do. And let's see if we can come up with a plan for how to do this. And this that I'm going to do here does not include programming. So this is just problem solving. There is an example on Canvas where there is problem solving and writing the code. So you can look there later if you like. But here for this one, all right, so we're going to come up with a plan. So what I want to do is that I want to have a starting point. And what is the first thing we need to do? Well, one thing is that before we do anything, we have to think about one thing. And that is that there are many different ways of making coffee. You could make instant coffee, you could make filter coffee, or there is other ways of making coffee. And it doesn't mention which one. So when we're doing assumptions, we have to write them down so that we know and anyone else that is later going to look at what we have done also know what assumptions we have done. And in my case, I'm going to make instant coffee. That is what I am going to try to give instructions for. And the first instruction for me would be to fill the water heater jug with water. And the next thing I want to do is to turn on the water heater, because it's not enough to just put the water in the jug. I also want to turn on the water heater. So that is my next step. And when we have turned it on, all right, now we have to start to prepare. So the water is boiling, but there are a few things we need before we can make instant coffee. So for example, we need to take out a cup from the cupboard. And all right, we have the cup, but what we also need is our instant coffee. So we need to take the instant coffee from the shelf. All right, we have the cup, the instant coffee, but we also need a spoon to stir it later on. And when we have all of these things, we can now use the water that we have boiled and put it into the cup. All right, we have the water in the cup, and only 2 steps left. We have to add some instant coffee. And we also need to stir for a bit. And then we are done. So it will maybe be a bit hard to read on the screen now, but here we have developed a plan for how to make instant coffee. I'm just reading the chat. Yeah, so there are some more options here, and we have made an assumption that our friend has a water heater. So we can see here that even if I wrote it down step by step, we can always find things that we could have done better. For example, we saw here that an assumption that they have a water heater, but we can also look here. We fill the water heater jug with 1 liter of water, then we turn on the water heater. We don't say anywhere that we put back the jug in the water heater. So it is tricky developing a flowchart or instructions for how to solve a problem. I'm just reading the last question here. Should we do this as precise as possible for our assignments, or would it be enough to describe something like a variable change, like change bag and meal variable? So the question is about how thorough you should be. You don't have to be super precise when you're doing it for your assignment, but it should explain what you're trying to do. So the example that you give there, change bag and meal variable, that is perfectly fine. All right. And as I said, there was a video on YouTube that you or on Canvas that you should watch for today. And if you haven't done, you can watch it later, where I do something similar, but where there is also some code involved. All right. Let's see if we can get back to our next slide. I will change it to PowerPoint, and I guess that it is not good enough, right? Or is it readable? It's okay, great guys. It's a little bit blurry, but I can read out what it says. So hopefully we can get through it. So it says, let's change to the next one. Integrated development environment. What is it? why do we use them, what different types exist, and what IDE will we be using in this course. So what is it? Well, if you want to make it simple, you can say that an IDE is a program that we programmers use to write our code in. And it's a graphical tool for editing text. It works like other familiar programs like Microsoft Word or so. It's just that we use it for writing our code in it. And why do we use it? Well, even if you can program without an IDE, we saw I used the terminal before, most people prefer to use an IDE as that software is developed to give us a lot of support as we are programming and writing our code. Some examples of support that we can get from an IDE is that we can run our code. Different parts of the code gets color marked, or it's highlighted in color. You can get help about the instructions that you're writing, and it can even autocomplete what you're writing. So if you start typing something, it can autocomplete it for you. And as someone write here in the chat, for debugging. So if something goes wrong when we're developing our script, and we can use debugging. So we can step through each instruction and have a look what is actually happening when we're running our script and try to find that nasty bug that is messing everything up. And there are different types. What different types exist? Well, everything from a very, very simple text editor to more advanced text editors that have some of these features, to dedicated development environments where you have many of these features. And I would say that the one that we will be using, Visual Studio Code, fits this category where we have many of these advanced features. But there are other types of environments too that can, for example, emulate hardware. So if you're developing for a mobile platform, then you can emulate having a phone so that you can see how it looks on the phone when it's done. So when the app is done, you can put it on your phone and it will run just as it did in your emulator on your computer. And I was thinking that we should have a sneak peek on how Python looks. So we will change to Visual Studio Code. Give me a second here. I will just see if I can get it up on my screen first, and then I will share it with you guys. Hopefully it will be good enough that it is possible to see what I am doing. We are not going to write much code, and I'm going to talk through it, so hopefully it will be okay. And if we start by having Visual Studio Code, which is the environment that we are going to be using, or at least that I will be using throughout the course. If you're used to using something else than Visual Studio Code, you can continue doing that if you like. But for anyone who's new to it or don't have a preference, I would recommend to use the same as I do, Visual Studio Code. That is also the one that you guys installed yesterday if you were to the help session. And if you weren't on the help session, I would recommend you to install it before lecture 3. But all right, if we have Visual Studio Code open here, let's see if I can create a new file. And when we create a new file, let's see if it shows up here too. You guys don't see the new file yet. I think it is lagging a little bit. Let's see. Let's try that again. If I create a new file, now it's showing up. Something to be wary of is that when we have created a new one, we should save it somewhere. Now you can't see what I am writing, but I am writing main.py, and we can see that now on the screen in the top of this tab that I'm on. And when we are creating our scripts here in Visual Studio Code, we should always name them with the extension .py so that Visual Studio Code knows that this is a Python script. And let us write some code in here. I'm going to write the same as we did before. I'm going to write hello world, and we can run it and see what happens. We can see that we get a window down here where it gives us our output, but there is actually something else that we can look at here. If I start to write print, it suggests to us, do you mean print? So it's trying to help us here. And yes, if it is printed, I can just press enter. And then when I continue writing, it gives us some suggestions or help for what the next thing we want to do might be. We won't go into this help at the moment, so I will just close it. Just know that it can help us with some help about the instructions that we are writing. So maybe we want to write something else. What did we have before? We will learn programming. So we add that one too. The quality has improved. Thank you so much for that, Zoom. Appreciate it. And thank you for letting me know. So if we run it, now we can see that it will run both of these instructions. And someone mentioned in the chat before about debugging. And what debugging is that we can run our script one instruction at a time. But before we try it out, I'm gonna create a few more lines here, or a few more instructions. So what I did here is that I created a variable. So I say, all right, the variable message will contain this text. And then if I ask Python to print the message, it will actually print higher again. So we can see how it works if we run it. We can see now it prints 3 things. But if we're going to use debugging, what we can do is that we can, if we click here to the left, we get a red little dot. And if we click it again, it disappears. What this means is that if we run this in debugging mode, when Python comes to this line, it will stop here and wait for us. So if we start debugging and we choose that, yes, I want to debug this file. See, let's give it a few seconds. We can see that, all right, it stopped here. It marked this line that, all right, the next instruction I will do is the one that's marked in yellow here. So if I click up here, we can see that, all right, now it performed that instruction and printed hello world. So I can go instruction by instruction. And we can even see here, now that I assigned hi again to message, we can see out here that it stored it here, so we can see it, all right? So we can see what's stored in each of our variables. And when we execute the next line here, which is the last one currently, even before we run it, we know that what it will print because we know what message contains. We can see it out here to the left. And this is really helpful when we are trying to find a bug in our script. And just to show one more example of this, I will add some more code here. And after I have added, I will explain what I did. Or I should balance, and we should have a salary is equal to 20, and the total is equal to, and here we can see now that if I want to write balance, we will get help right away. So Visual Studio Code is trying to help us by saying, oh, do you mean balance? And if it is this I mean, I can just press enter and I don't have to type everything. The same with salary. And we can see it in action again here when I want to print it. As soon as I start typing total, it will give me a hint. All right, is this what you mean? If so, just press enter. Now if we run this again, I will move the red dot down to here, and I will go to run and start debugging. Oh, is this file I want to run? We can see that it has already run through this line here, this instruction, and saved hi again in message. So we can see that we have it out here, and we can see that it has printed all of these three things already. But now when we continue, we can see that the variables one by one is added out here. So if we imagine that we have a bug when we are trying to calculate total, what we can do is what I did now, and then we'll see exactly what values balance and salary have when we get to this line of code. And maybe they don't contain what we think that they contain, but now we can see exactly what they contain. And in this case, the result is correct, and then we print it finally. So a very, very, very quick introduction to debugging. I just want to show it now that you're going to start to program next week or before next week when you're preparing. It could be good to know about if something goes wrong when you are running your script. So remember, put a red dot, go to run and start debugging. All right, let's switch back to our PowerPoint, I think. And we're almost done for today. It was a very quick introduction filled with a lot of technical difficulties. I'm not sure why the quality was so bad in the middle. And I see even now that I'm lagging a little bit. I have no idea. I'm very sorry for it. I hope you can forgive me for it. But there are a few more things I want to mention before we end. You should never hesitate to ask questions. You're more than welcome to ask me or my teaching assistant any question that you have. There are no stupid questions. All questions are good questions, especially if you have never worked with programming before. It can be intimidating, and there might be times that you're struggling. Don't hesitate to ask us questions. And you can also use the Discord server that you guys have and ask questions there. I'm just going to read this chat here. There was one question if you need to declare data types. No, you don't have to do that in Python. And yes, you can run VS Code from Anaconda if you like. Will we be able to take the first quiz with the knowledge we gained today? I would say wait and read and prepare for the next lecture. So the first quiz will be on what you prepare for lecture 3. So the things that you should read for lecture 3 and the videos to watch for lecture 3. So do that first. Read the chapter in the book and watch the videos for lecture 3. Then take the quiz. But the quiz should be done before lecture 3. A question about the book. The answers to the first quiz in the book don't relate to the questions. I have a question regarding the book. Let me just read it one more time. Oh, I'm not sure. I have to look that up. If there is a mismatch between the answers and the questions in the book, I'll have to look into it. Maybe if you bring your book when we have our first exercise, then maybe it's easier to look at it and we can see what it is. All right. So don't hesitate to ask questions. Oh, one more question. Can you repeat again the difference between the interpreter and the compiled language? Yes, of course. So the difference between a compiled language like C or C++ and a interpreted language like Python is that if you have a compiled language, you write your code, then you use a compiler which directly translates your code into something that the computer understands, to ones and zeros. And then when you want to run it, it's already translated into something that the computer understands, so you can run it right away. But if we have an interpreted language, we write our code still, of course, but then when we run our script, the interpreter have to read one line of our code, translate that into something that the computer understands, and run that. Then the interpreter goes back to our code, fetches the next instruction that we have written in our script, translates that into something that the computer understands. Then the computer can run it. So basically that is the difference between the two different ways. Compiled translates everything in the beginning, then you have an executable file that the computer understands. And interpreted languages uses an interpreter when you want to run it to take one instruction at a time and translate it. And no, compiled language will not run on every platform because that is compiled into something that platform understands. All right, and while I wait to see if there are more questions, I'll just mention something about today. So we looked at we talked about the hardware of the computer, and that maybe we should have an idea of what the different parts are, but we don't have to go into detail. We should know that there are different types of programming languages, like we just mentioned, compiled and interpreted. And in Python, there is a difference between the two modes, interactive and script mode. We should know about it, even if we in the course mostly or exclusively use script mode. It's good to know about interactive mode because you will read about it in the book or in other sources so that you know what it is. And we looked at Polya's problem-solving techniques, and we should know how it works, and we should be able to use it. Just waiting to see if there are more questions. Just write the questions in the chat if you have any. So for next week, we have lecture 3 in the beginning of next week. And what you should do to prepare for lecture 3 is that you should read in the course literature the chapter listed under lecture 3, and you should watch the videos. You should also do the quiz before the lecture. it's important that you do it before the deadline. And then during the next lecture, lecture 3, I will have a short introduction, and then you work with the tasks on lecture 3. So you don't have to start with the tasks before the lecture. You're of course more than welcome to, if you like to, if you want to work ahead a little bit, you're more than welcome to do that. I see that there are a few more questions. I'll just take a read here. How do you recompile code for another platform? What you do is that you would take the code and give it to the new or to the other platform, and then you have to compile it on that platform. So for example, if we have a program that I compile on my Mac, it will run on my Mac and other Macs. But if you want to run it on a Windows computer, you have to take the source code, our instructions, and I give it to you, for example, and then you can compile it on a Windows computer. Then you can run it on Windows. It is not mandatory to take the quizzes, not at all. So they are optional, but do know that there is a deadline, and after the deadline you cannot take the quiz, meaning that if you do decide not to do the quiz for lecture 3 now, you cannot do it later. So the intention is that throughout the course you should work with the material. So you should prepare for lecture 3. You should read the book and watch the videos and do the quiz before the lecture. But it is not mandatory. They are optional. The benefit of doing them is that if you get 75% correct, as we talked about, on all the quizzes combined, you will get 2 extra points for examination 1. Videos you can find on external resources on Canvas. So under external resources, you can find them. Yes, so the deadline is before the lecture. The intention, as I said, is that you should prepare before the lecture. Yes, the quizzes have a limited number of tries. There is only 1 try. So there is a deadline and you only have 1 shot. So that means that you have to prepare before doing the quizzes. Oh yeah, and you mentioned it in the chat afterwards here. Thank you so much for helping out. I just missed that. Someone else here is asking if you have already done solve the problems, if you can upload them, and yes you can. So if you have started working with the material in the course and you have already started working with the problems for examination 1, yes you can upload them. And something that I maybe should mention here is that when you upload them, you will see that the code grade, which is the tool that automatically corrects them, the uploads, it is very picky, and that is by intention. So even if you write the correct answer but in the wrong way, it will tell you that it's wrong. So you must match the output to what is mentioned in the task and in the automatic tests. This is so that we as programmers are forced to be very careful and thorough with what we do, but also so that I can check that you can format your output. And if you want to upload them now and just try to upload them and see how it goes, it will require you to upload the report too. But if you just want to try it, you can just have an empty report and upload it and see if everything works. And if it does, then you can fill out the report afterwards. And let me just read here. So VS Code is the program that we use to write code, and what I did today was a sneak peek of what you will do next week. So even if you didn't get it all today, don't worry. When you read about it in the book and watch the videos for next week for lecture 3, this is what they will talk about there. Yes, so someone asked here if it's the capital letters and symbols, and I guess that is in regards to when you upload your examination 1 problems. Yes, so it should be the same text as is expected. So for example, you cannot print, let's see if I can come up with an example. If the test is that it should print 1 bag, then even if you write 1 and then you have 5 spaces and bag, that will be wrong because it expects just 1 space after 1 and then a space and a bag. So the output must have the same format. I hope that makes sense. But don't worry, even if it gets wrong, you can just look at what the error is and then you can go back and correct it. So the intention is that you should use this tool to improve the script over and over again until it passes. Yes, you do get hints. If you upload and you fail, it will give you hints what is expected. Just read it carefully and it should give you hints on for example, that you have too many spaces in your output or something. Something like that. Someone here asked about the report. So the report, there will be a template that you download under each of it's the same template, but it's linked under all the problems. So you download that template and you use that one in Microsoft Word to write the report. And there are instructions in the template for how to do that. Yes, so word for word, number for number, and symbol for symbol should be as it is expected by CodeGrade when you upload it. What about the text we asked the user for input? So when you upload it, if you in your script are asking the user for something, there will be tests where it's automatically inputted. So if the task is that you should ask the user to input a menu choice, that will be automatically done by the automatic test. So there will be a test trying, for example, to input 1 and see what your script does and that it reacts correctly to that. If there will be feedback for the report, yes, but there is not automatic feedback for the report. So the report is only read after the deadline. There was a question about if it's only about the output, and the automatic tests, there are different kinds of tests. And here in the beginning, it is mostly about the output of the script. That the output matches what is written in. It changed. Let's see. We can change to this maybe. That it matches what is in the task, but later on there will be automatic tests that checks different parts of your code too. So for example, if it is in the instruction that there should be a function in your code that works in a certain way, that will also be tested automatically, that it is like that. But other than that, it will not look at every instruction that you write in your script. The last question here, there is a section if there was something that you found tricky. And if there isn't anything that you found tricky, you can just write that. There was nothing from the task that I found, or from the instructions that I found tricky. I understood it when I read it. So yes, in a way you can leave it empty or just write that you understood everything. Are there any more questions, or is there any questions that I maybe have missed? We will take a look at CodeGrade before the deadline. I think there is a help session on it too. But I was thinking that maybe we can use one of our exercises to have a look at how to use CodeGrade. You're more than welcome to start to try to use it now and just try it out. There is no harm in doing that. There is no harm in uploading a script that doesn't pass all the tests, because you can just upload as many times as you like before the deadline. So don't worry, you can try it out. But I was thinking that maybe we can use one of the exercises too, where I can show it off a little bit more. Let's see here. There was one more question. What should be done for exercise 1? So before exercise 1, what you should do is that you should finish the tasks from lecture 3. So if I just quickly mention what we should do next week, so before next lecture, which is lecture 3, what you should do is that you should read the book and watch the videos, and then do the quiz if you like to do the quiz. It's not mandatory, but if you want to do it, you do the quiz before the quiz deadline. Then after that, there is the lecture 3, where I will have a short introduction in the beginning, and then after that, you will work on the lecture tasks. So you start working on the tasks, and even if we are online, there will be a possibility to ask me questions if you get stuck. And then you continue working with the tasks until you finish with them. Then we have the exercise later next week. And before the exercise, you should go in and look at the exercise task and make sure you read them through, that you understand them, and maybe start thinking about how to solve them. So if you think about Polya's problem-solving technique, it's the first steps. And then during the exercise, you will work on the tasks. And for the exercise, we will be at campus. You can find all the tasks if you go to Canvas and then go to modules. And under modules, you will find lecture 1, lecture 2, lecture 3, and so on. And under lecture 3 will be the first tasks to work with. And then there you will also find exercise 1, where the exercise tasks are. But if you're wondering where the examination tasks are, you will find those under assignments. So not under modules, but under assignments. So yes, and you can use Visual Studio Code. You can use that, yes. Any more questions? All right. Thank you so much for today, everyone. And I'll see you next week. And don't hesitate to contact us if you have any questions. Bye, everyone.